Hi guys, as promised, a bit of an explanation on the merit and excellence as requested by quite a lot of students in the class. My apologies for being late. Some things were out of my control. But anyway, here we go. Achieved, sorted, merit. We in class came up with that, and we identified that this system is dependent. And we also found out that it's actually two equations forming to give the third. And here's a geometrical representation. You can get away with without doing this, as long as you give an example of how actually two equations will combine to give the third. So to speak, securing that high grade. Now, excellence. Please feel free to pause the video and look at my working. The different colors are just showing elimination of X, Y, and Z. I eliminated X on paper using three different combinations of working like this. So I used equation 1 and 2, and I ended up getting that. I used equation 1 and 3, I still got that. I used equation 2 and 3, I still got that. Likewise, for eliminating Y, I ended up getting that. For eliminating Z, I ended up getting that. So those three equations are very powerful. They will help you determine the upper and lower bounds of X, Y, and Z. Once again, please pause the video and read everything here. That part is very important. I've made Y the subject, and I have created an inequality. Now, since Y is greater than 0, obviously the other side has to be greater than 0. This enabled me to find a lower limit of Z. I got 29.33. Obviously, you need integer values, positive integer values. So Z must be greater than or equal to 30. Likewise, I did working here, and I got the upper limit of Z. Using this equations here, I ended up getting X is greater than 0, obviously. And solving this gave Y is less than 28. I have avoided some working here, which I'm sure you can catch up on doing. I found out that Y minimum must be greater than or equal to 0. In fact, Y is like a negative number, so practicality applies. Y must be less than 0. Working smart, use the upper and lower bounds of Z, plug it in those that equation there. You end up getting two different values for X. So that becomes the lower value, that becomes the upper value. And we have got there's these highlighted stuff, gives you the limits of what X has to be in between. I will show you how to get some actual values, because you need to display around at least two. So for that to happen, what I've done is I've opened a Microsoft Excel file. You can use your calculator as well. I'm sure you know how to use a graphics calculator. So what I've done is scrolling down here, it's disappeared. Scrolling down here, I've taken this equation very quickly. Where is it? That one there. Let me put it down here. Now I have made Z the subject in here. Now to make Z the subject, you all would know by now what kind of maths to do. X negative 88, take away Y, and very quickly, I should have done this, sorry folks. Insert it. Where's my equation? Okay. Don't want to waste time, so I'm gonna go do that. Divided by, I'm sure it's negative 3. So what I've done is this. I know for a fact that Y minimum is 0, and Y has to be an integer value. So the next number up is 1, 2. Just ignore X and Z columns for now. So the largest value I've put up is 28 for Y. Z is equal to negative 88, take away Y, and divided by negative 3. That's exactly what I've done here. So if I bring up my calculator very quickly, bracket -88, take away 0, 0, because that's my y value here, and I'll divide the whole thing by -3. Ta-da! I got 29.33. Then I go and quickly change the 0 to 1. I get the next number. Then I'll change the 1 to 2, which is the next y, so on. Okay, I'll change that to 3. Ta-da, ta-da, ta-da. So I'll get those values. So Microsoft Excel has done that for me, and I'll just click to drag down, and I got all the possible values of z provided y is that value. Likewise, I used that equation, this one here, and I made x the subject, so x became 56 minus 2y. So what happened here was this value came about by going 56 minus 2 times 0, which is 56. This value came about by going 56 minus 2 times 1, which is 54. 56 minus 2 times 2. 56 minus 2 times 8, so on. And I got pretty neat values for x and y. Actually, they are integer values. However, z has some fractional or decimal values. So for practicality, you need to ignore the solutions with those decimal or fraction answers. Okay, so delete them, and you only hold on to the positive integer values. So I've already done that here, and that's what I got. So those are all the possible solutions which will satisfy the new requirements for $888 of sales, 2,000 grams of cheese usage on one particular evening, and 2,880 grams of vegetables used, provided that each mini pizza is sold for $8. So this here is just me checking out my own work. I went $8 times 52 plus $11 times 2, which is $22, $15 times 30. That when I added up those three numbers, I got $888. Likewise, $20 times 52 mini pizzas, $30 times 2 regular pizzas, 30. Did I say $30? Apologies. 30 grams per 2 regular. So 30 times 2 is 60. This is 30 times 30 is 900. When I add them up, I get 2,000 grams of cheese. So this is without any wastage. We're not wasting anything. It's all being consumed as per the new requirements in the worksheet. I'll just quickly jump to one of these random ones here. So this came about by going 20 grams of vegetables per mini pizza. So 20 times 4, 80, 20 times 26, and blah, blah, blah. I got perfect. So I got perfect answers. So I only need to give two integer solutions. When I say two, I don't mean like two like that. I mean like XYZ and maybe XYZ, but with working. So yeah, there it is. I hope that helps. Thanks.